Hi everyone, today we are going to discuss about nice domains and ugly domains. Before going into the topic, let us know what is a domain and domain test. Domain. A domain is a set. It is a variable or a combination of variables. For example, let us consider a set 1, 2, 3, 4, 5. It is a domain with 5 values and it has 5 integer values having boundaries 1 and 5. Here 1 and 5 are the boundaries. These boundaries are also called as domain boundaries. A domain can be divided into subdomains. I am considering the above set which I am taken previously 1 2 3 4 5. This 1 2 3 4 5 domain is can be divided into subdomains. That subdomains are shown below here. When there is a domain, there must be a predicate because we have to decide the domain boundaries with the help of predicates. Let us consider another example for explanation of domains. Here I am considering an variable called I, which is a integer variable. Here integer is a domain with domain boundaries minus 32,002 plus 32,000. Same domain boundaries are assigned to I because I is declared as integer variable. Previously said that a domain can be divided into subdomains. Here integer domain is divided into subdomains like this, int I and int j. But the boundaries of the I and j are decided by using the predicate only. Without predicates we can't decide the boundaries of I and j. Finally, a domain is a set of values and it can be divided into subdomains, and the boundaries of the subdomains is decided by the predicates. Without predicates we can't predict the boundaries of the subdomains. We are moving to another topic called domain closure. What is meant by domain closure? If the points on the boundaries belongs to the domain, then we will tell that the particular domain is closed. Let us consider an example. In this example I am taking 3 domains d1, d2 and d3. Here these domains are shown in the below figure for easy explanation. Here d1, d2 and d3 are the domains with boundaries. Figure is showing that d2's boundaries are closed both at the minimum and maximum values. That is minimum and maximum values. That is both points belongs to d2. This point is belongs to d2 and this point is also belongs to d2. If the points belongs to a domain, then the domain is said to be closed. Let me explain this example by taking the values for the domains. Let us consider the values for d2 is equal to 1, 2, 3. Here 1 is present at this point and 3 is present at this point. According to the definition, if the boundary points consist of domain values, then that particular domain is said to be closed. In this figure, d2 is closed on both sides, means both minimum and maximum points consist of d2 values. Here d2 is a domain, it consists of values. Those values are present in minimum point and present at maximum point also. So domain d2 is closed on both sides. Consider the below figure. Here I am representing the d2 domain is closed and I am showing this as a shaded part at minimum point and maximum point. Whenever the d2 is closed, d1 and d3 are opened, means that the points are not belongs to d1 and d3 at minimum and maximum points. Here minimum and maximum values are explained with by taking an example. Let d1 is the float value, means it is a float domain, and d2 is the integer value, means it is an integer domain, and d3 is a character value, means it is a character domain. For d1, minimum value is decided by the predicates. For example, our predicate is minimum value is minus 32,000 and maximum value is plus 32,000. Here minus 32 and plus 32,000 values are here. Here on minimum value, and if an integer value is present, then that value belongs to D2 domain, so that here D2 is closed. On the maximum value, in this point, if there is any D2 domain value, then it is said to be closed. A small correction, here it is a D2 domain. By this example you can understand minimum and maximum of domain values, and which is closed and which is not closed. Let us take another example. Here this is another example. Here D2 is closed in one side and D2 is opened in another side. Here it is closed and here it is opened. Here opened means the points of the D2 values are not present in the maximum value or maximum point. Here D2 is closed on the minimum side and open on maximum side. Here D1 is opened at minimum of D2 and D3 is closed at maximum of D2, which means that the values of D1 domain is not present at this point and the values of D2 domain are not present at this point, and the values of D3 domain are present at this point. That is why we are calling D3 is closed here and D2 is opened here. Let's take another example here. Here for D2 domain, both ends are opened. Here minimum value and maximum value both are opened here, and we are going to tell that boundaries are closed for D1 and D3. Why? Because D1 values are present at this point, because D2 values are not present at this point. Here also D3 values are present at this point, as well as D2 values are also not present at this point. That is why we are calling D1 is closed here and D3 is closed here and D2 is opened here and D2 is opened here. Like this, domain closure is defined. Every input variable adds one dimension to the domain. One variable defines domains on a number line. Two variables defines planar domains, and three variables define solid domains. Let us move to another topic called domain testing. Domain testing attempts to determine whether the classification is or is not correct. In domain testing, processing begins with a classifier section that partitions the input vector into cases. An invalid input is just a special processing case called reject. The input then passes to a hypothetical subroutine or path that does the processing. In domain testing, we focus on the classification aspect of the routine rather than on the calculations. Here a semantic representation of domain testing. Here we are going to give the input variables. That input variables and values are classified here, and according to that classification we will use to run these cases. According to these cases we will generate the output. Let us explain this diagram with an example. Here we are going to give inputs of three different domains. One is integer domain, and another one is the float domain, and another one is character domain. These three domains are classified here. According to that classification, these cases are generated. In case 1, integer domain is tested according to the boundaries. In case 2, float is tested. Domain testing can be based on specifications and or equivalent implementation information. If domain testing is based on specification, then it is a functional testing technique. If this domain testing is based on implementation, then it is a structural technique. So the testing technique is based on specification and implementation. Based on those specifications and implementations, domain testing is decided as functional testing technique or structural testing technique. Here there are two types of domains are present: nice domains and ugly domains. Nice domains are represented in a figure, which is typically two-dimensional domains and satisfying some of the important properties. Those properties are mentioned here. The properties are: if a domain is nice domain, then it have linear boundaries and complete boundaries, systematic boundaries, orthogonal boundaries, consistently closed boundaries, simply connected boundaries, convex boundaries. This figure shows the two-dimensional domains. Here D11 means domain 11, domain 12, domain 13, domain 14. each and every domain two dimensions are there, v1 and u1, v2 and u2, v3 and u3, like that. Here v1 and u1 are the boundaries of the domain. Each and every domain must consist of boundaries. Two boundaries are here showing, that is why we are calling it as two-dimensional domain. These domains are nice domains. Why we are calling these domains are as a nice domains? Because these domains satisfying the properties that are, these are the different properties that are satisfied by a domain. If domain boundary satisfies the properties, then the domain is called as nice domains. These are the boundaries, different types of boundary properties that are listed here. Let us discuss in detail each and every property. First property is linear boundary. Nice domain boundaries are defined by linear inequalities or equations after interpretation in terms of input variables. Another property is complete boundaries. Here nice domain boundaries are complete in that they span the number of space from plus to minus infinity in all dimensions. To explain this complete boundary, let us consider an example here. This is the example for complete boundaries. In this figure shows some incomplete boundaries. Boundaries A and E have gaps. So if there is any gaps, that is not a complete boundary, and the domain is also not a nice domain. If there is no gaps, then it is said to be a complete boundary, and the domain is also called as nice domain. See here A is not completed, it having gaps, and here also it having gaps, that is why it is not a complete boundary. And E also not completed, here it is having gaps and it is having gaps here also, that is why it is not a complete boundary. If there is no complete boundaries, means it is not a nice domain. Complete boundaries only considered as nice domains. Another property called systematic boundaries. This property also satisfied by the domains. If this property is satisfied, then the domain is also called as a nice domain. In the systematic boundary, it means that boundary inequality is related by a simple function such as constant. This is also shown in the another figure. Let us take this example to explain the systematic boundaries. In this figure, the domain boundaries for u and v differ only by a constant. U and v differ only by a constant. Then it is said to be a systematic boundary. See here, it is differing by only a constant. Here 1, here 2, here 1, here 3, here 1, here 4, here 1, here 5. Like this, systematic boundaries are different. Next property is orthogonal boundaries. If this property is satisfied by the domains, then that domain is called as a nice domains. Let's see what is meant by orthogonal boundaries. Here u and v boundary sets in the figure are orthogonal. In this figure, u and v boundary sets are orthogonal. That is, every inequality in v is perpendicular to every inequality in u. If two boundaries sets are orthogonal, then they can be tested independently. Next property is consistently closed boundaries. If this property is satisfied by the domains, then the domain is called as nice domain. Let us see what is consistently closed boundary. Here, boundary closures are consistent and systematic. Consistent closure means that there is a simple pattern to the closures. For example, using the same relational operator for all boundaries of a set of parallel boundaries. Another property, simply connected boundaries. Nice domains are simply connected. That is, there are in one piece rather than pieces all over the same way with other domains. Next property is convex boundaries. A geometric figure is convex if you can take two arbitrary points on any two different boundaries, join them by a line, and all points on that line lie within the figure. Nice domains are convex. That means the domains which are consisting convex boundaries, then the domains are called as nice domains. This is all about nice domains. In our next lecture we will go through ugly domains.